Hello everyone, what is going on? It is teacher Julino again, aka Mr. Epalanga, and today we will continue talking about alcohol as we have done in our classes. So today we will start with the physical properties of alcohol and we will carry on from here. And since this is a revision class, so I'm not going to spend much time here, but hopefully will help you to eliminate any possible doubts you may have, as well as prepare you for our next lessons. Okay, so physical properties of alcohol. So we need to see or to remind ourselves that alcohols are made up of two parts. The first part is non-polar alkyl group, and the second part is the polar hydroxyl group. So these two parts will determine how this alkyl and hydroxyl, non-polar and polar parts, respectively, will affect the properties of the molecules called alcohol. Now, as we said, we have the R part, the R group, and the OH group. So the R group are non-polar, and the OH groups, these guys are polar. Okay? Now, we have one example here. We have in figure hydrogen bonding in alcohol molecules, and picture or figure B hydrogen bonding in water molecule. Let's look at water molecules first. Now, in water, we can see that the oxygen is bonded to two hydrogen bonds. Now, the hydrogen here, the first hydrogen with oxygen makes OH, which is the hydroxyl group we have in alcohol. Now, this oxygen and hydrogen, they have a very different electronegativity values, which make the oxygen slightly negative and the hydrogen slightly positive. So the symbol we have here, delta means a small and plus a small positive charge, small negative charge. So this side of the molecule is slightly positive, in this side are slightly negative, and the hydrogen part are slightly negative or positive rather. Now, what we see here is an attraction, okay, between the positive side and the negative side of the molecule here. So this attraction is what is called hydrogen bonding. And of course, it is much stronger in water than in alcohols, because water is, the OH is bonded to one hydrogen atom, whereas in alcohol, it is an alkyl group. Now, we could have an example for what we have H, and then we have oxygen here. So this side is slightly negative, and this side is slightly positive. What happens is that the negative side is attracted to the positive side of the other. In this case, we have water here, okay, and then we have H. So this negative side of the molecule attract this positive side of the molecule. And this attraction is what is called hydrogen bonding. Now, what we have here is that this part will determine the physical properties of alcohol. So now, for alcohol, instead of hydrogen here, we have an alkyl group, which is a much larger, okay, are much larger atoms, okay, much larger elements than hydrogen, and therefore they are more non-polar. So they are non-polar. It means that the alcohol will have one part of the molecule which will be polar, and the other part of the molecule, which is the alkyl side of the molecule, which will be non-polar. So one example would be propyl alcohol, for example. We have CH3, CH2, CH2. So this is propyl, and when we add OH, it becomes propyl alcohol, or if you prefer, when the IUPAC name becomes propanol. Now, propanol, this part is non-polar, polar rather, because it's where we have the OH. So this part is polar, and that part is non-polar. Alright, now we can see that if we have, for example, the OH, which is polar, makes the molecule more soluble in water. Now, it means that if we have many OH groups, the alcohol will be more soluble in water. So one example I'll give you is, for example, if we have glycol, which is glycol is CH2, CH2, OH here, OH here. Now, we have two carbon and two OH group, and then we have ethanol or ethyl alcohol. It should be CH3 here. Now, we only have one OH group. It means that this alcohol here is more soluble in water, okay, than this one, because we have two OH groups here and one here. So the more OH, the more soluble, and also the higher the boiling point. Now, if we have, for the same OH groups, if we have more carbons, for example, if we have now here propyl alcohol or propanol, CH2, CH2, OH. Now we have 3 carbons and 1 OH group here, and we have 2 carbons and 1 OH group. It means that this compound here will be less soluble. Will be more soluble because this part here is small, okay, is smaller compared to the propyl. So ethyl, we have 2 carbons, propyl, we have 3 carbons, so this will be more soluble in water compared to this one, okay? Now, if we add another compound with 2, okay, 3 carbons, 2 OH groups, but here we have 2 OH groups. So this is more polar, it means this compound will be more soluble compared to this one. Okay? Now, other important thing we have to also see is branching. When we have branch, okay, branch increases the boiling point and solubility as well. Because branch reduces the van der Waals forces effect. Okay, I'll explain what we mean by that soon. Okay, let's see here. Now, when we have, for example, if we have CH3, CH2, 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 OH. Okay, we have 1, 2, 3, 4 carbons, and we have CH3, CH, CH3, and then we have CH2OH. Now, we have 4 carbon, but in here we have a straight chain and here we have a branch. So, when we have a branch, it means that there is less space for contact between the molecules. This part here, these molecules here, they kind of cover this molecule. So this molecule cannot interact with other molecules. So the van der Waals forces in this compound, okay, are lower or are smaller compared to this van der Waals forces here. There is more room for contact with other molecules here. That's why branching will increase. Branching will increase solubility and will decrease the melting point. So branch, when we have a branch, it will increase solubility, okay, will increase solubility and will decrease, okay, will decrease boiling point, will decrease boiling point. Right, now, we've seen the OH, we've seen branching. What about the number of carbon? Of course, the more carbon we have, it means that the more non-polar the molecule becomes, and it will increase the boiling point and the melting point because it increases the van der Waals forces, but it will also decrease solubility because it is more and more non-polar. Okay? It's more and more non-polar. Alright, so for today, I think that's it. This is just a revision. We don't have much to cover on the physical properties. If you guys still have any question related to physical properties, do not hesitate to contact me through email or WhatsApp because the contact will be provided to you. Alright guys, so I enjoy the rest of your day. Stay blessed and stay safe.